All right, you tens, while I'm out at the softball, you're going to work through 2H. But what we'll do is we'll just look at exercise 2G for a bit and talk quickly about compound interest again. So it'll be a good bit of review to start this lesson. So a reminder that the formula for compound interest is A equals P, the principal, multiplied by 1 plus whatever the rate is, over 100, to the power of n compounding periods. Okay, so let's see how that relates to these two scenarios. So what we've got is $8,000 invested, I believe, at the end of 3 years. And this first scenario has it compounding at a rate of 12% annually. All right, so this one is, because it's just an annual compound, then this one is going to be a straight insertion into the formula. So this is A equals the principal, so it's 8,000 multiplied by 1 plus whatever the rate is, 12 over 100, and it's 3 years. That means 3 compounding periods. So that'll be an amount. All right, now this one here is the same interest, 12%, but instead of compounding annually, it compounds biannually. That means twice a year. So we're going to have to make a few changes to our formula. So it's going to be 8,000 still as the principal, multiplied by 1 plus. Now the rate this time, we can't put 12 in there because if it compounds biannually, that means we're going to give someone 24% interest, and that's too much. So we need to work out how we can give out 12%, but do it twice a year. And so that will be, or that will mean that I give out 6 after 6 months and another 6 after 6 months, meaning 12 for the year. So it's going to be 1 plus 6 over 100. Now this is the number of compounding periods. So it's done 3 years and we're doing it twice a year. So that means that this is going to be to the power of 6. All right, now what we'll do is just go over to our calculator and run those numbers. Okay, so whoops, we don't want to do that. New document and calculator. And so all we'll do is 8,000 multiplied by, open your brackets, 1 plus, we'll go a control and divide to get the division, or to get the fraction template rather, power of 100, and then we're going to go the hat key and 3. All right, so to get an approximation, we'll go control and enter. All right, home phone's ringing there in the background, and probably some market researcher or something. Anyway, I'm going to keep going. $11,239.42. So that's that arrangement. Now this one here, when it compounds biannually, that's going to be a better deal because even though it's still 12% interest, they build on it twice a year. So we'll just simply grab that formula, and the way to do that on the calculator is you press the up key, so I hit this one here and I hit enter, and it just recopies it in, and then you just have to edit it. Okay, it just saves a bit of time there. So that's going to be a 6 and that one is going to be a 6. Control enter for the approximation, and we get 1 1 3 4 8 1 5. Okay, so we can see that that's slightly better. So after 3 years, basically, we can take this amount here, subtract the first one, and we can see it's better. So we'd say part 2 is better by $108.73. So it's just a better deal. So the more often it compounds, the better for your investment. Conversely, if you're taking a loan, okay, the less often it compounds, the better. Speaking of investments and loans, that's what we're going to cover today. So when you invest money, the institution, okay, this is like a bank, or as the notes say, a credit union, pays you interest. When you borrow money, the institution from which you borrowed charges you interest, so you must pay back what you actually borrowed plus the interest. So usually when you take out a loan, what you do is you agree with the bank to make these repayments. So usually each month or each fortnight or whatever the plan is. And you're going to repay the loan plus the interest within whatever the time period is. So let's see how this might work. Jacob takes out a personal loan of $13,000 to buy a car. He makes regular or repayments monthly for 2 years at $680 a month. Find the total cost of the car. Now you might think that the answer is $13,000, which is the total cost of the car, but it's not. Okay, and let's find out what Jacob actually has paid for the car. So he's making repayments monthly for 2 years, $680 a month. So that's 2 years, which is 12 months a year of $680. And what I'd be willing to bet is it's going to be more than the $13,000. And the reason for that is that Jacob is paying interest as well. So we're going to go 2 times 12 times 680, and that's going to be 16,320. Okay. So the interest charged on the loan is going to be simply the amount Jacob paid, which is this amount, subtract what the actual cost of the car was. Okay, so this one is going to be 16,320, and we're going to remove the actual cost for the car, and what's left over is the interest. Okay, and you might ask, well, why would you do that? Why wouldn't you just pay the $13,000 for the car rather than pay the bank or whoever it is $3,320 extra? And the reason is Jacob probably didn't have the money for the car, might have needed the car for work or something like that. So this might be a good investment, given that without the car Jacob might not be able to work, etc., etc. So some people don't have a choice. They can't avoid these arrangements. All right, so the next one, we've got Sophie paying $3,180 for a holiday apartment rental on the following terms. She's got to pay a 30% deposit, okay, and then monthly repayments of $195 for 1 year. Okay, so what we're going to do is work out the deposit paid, and that's going to be just 30% of whatever the rental costs. So that's 30 on 100 times 3,180. Okay, and she's going to pay $954. All right, the total paid for the apartment, so it's going to be the deposit plus she's making monthly repayments of $195. So it's $195 for 12 months of the year. And this is how much she's actually going to pay, which again is probably going to be more. So it's 954 plus 195 times 12. So that's going to be 3294. So again, the interest charged, all we do on the calculator is we take the amount actually paid from the cost, which is 3,180. So it's 3294. We remove 3180 and we get the interest paid, which is $114. And that's not a bad deal if, again, Sophie didn't have the money in the first place. It's not a huge amount of interest. Okay, the final example that we'll do, an account has a minimum monthly balance of $180 and is credited monthly on this amount at 2.2%. So determine the amount of interest to be credited at the end of the month. All right, so we've got $180, and then we're just going to work out what 2.2% is of 180 and add that. That's the interest that the bank's giving you. All right, so it's 2.2 over 100 times 180. And that is $3.96. So that's very generous of the bank. They're giving us almost $4 at the end of the month. But here's part two of the question. If the bank charges a fixed admin fee of $4.50, which they do often charge a fee, don't know whether it's $4.50, and other fees, whatever they might be, totaling $1.18, what will be the net amount credited or debited to the account at the end of the month? So we know that the account starts at $180 and gets $3.96 interest. But what we need to then do is remove these fixed charges, okay, which is $4.50 and $1.18, their fees. Alrighty, so let's find out what's going to happen, and I'm afraid it's not good news. 180 plus 396 gives us $183.96, and then we need to remove, okay, so we're going to remove $4.50, $4.50 plus $1.18. So it's $178.28 in the account, okay? So the net amount credited or debited to the account at the end of the month. So actually this account goes down by, let's work it out, it had $180 and we're removing $178 from it. It goes down by $1.72. That's bad. All right, so now what I want you to do is just flip to the exercise, and there's a handful of questions there for you to do to practice these skills. Good luck with it, folks.